In this video, we'll be looking into the important concepts of third module. So in the previous video, I had explained about the important questions module wise. So as an extension to that, in this video, I'll be discussing the answers of third module, SQL advanced queries and database application development. So starting from the attribute, data types and domains in SQL. So there are nearly 8 attributes actually, 8 attribute data types. So the first one is numeric. So in numeric, we have size, integer and small int. So of various sizes. If the numbers are of floating type, then we have float, real and double precision. So, and then we have numeric I comma j and DEC I comma j, where I depicts the precision, the total number of digits, the total number of decimal digits, and j tells us about the scale, that is number of digits after the decimal point. Then we have second, we have character. So that is char, fixed character length, and then varchar, variable character length, and then CLOB, that is character large object. Then in bit string, we have bit, which is one, the answer would be in 1 bit, right? Then we have bit varying, and then, sorry, it would be in bits, sorry, it need not be 1 here. And then we have blob, that is binary large objects. Then in Boolean, we have either true or false or unknown. Then for date, we have the date of this format, year first, then month, and then date. For time also, hours, minutes, and seconds. Then we have time with time zone, so that the time along with time zone would also be specified here. Then we have timestamp, in which date and time both are written together. Then we have interval here. So to specify the data type of each attribute, we make use of domain, and the domain name used within the attribute specification. By doing so, we can improve schema readability. For example, creating a domain for SSN would be by the following statement, that is create domain SSN type as character 9. So here we are specifying the data type also. The constraints are being defined here. Next, we'll look into the definition of tuple. So it is mapping from attributes to values drawn from respective domains of those attributes. So it is intended to describe some entity or the relationship in the mini world. So for example, a tuple for a person entity might be name and then sex and then IQ. So this is for an entity of named person. Okay. Let's move on to the next topic, that is aggregate functions. So there are 5 aggregate functions. So they are used to summarize info from multiple tuples into single tuple. So the input functions are count. A count is used to know the entire count, and then we have max, maximum value in the given tuple, and then we have minimum, and then here we have sum, and then average here. So writing a common example for that would be select sum from salary, maximum of salary, minimum of salary, average of salary, and count of salary from employee. So this is about aggregate functions. Next, we have assertions and triggers. So this is a pretty important topic. So in SQL, users can specify general constraints via declaring declarative assertions using the create assertion statement. Assertion is, we make use of, we introduce certain constraints in order to derive or prove something. Okay, so for doing that, we assert the given condition. That is what assertion means. So we make use of create assertion statement of data definition language. So each assertion is given a constraint name and is specified via a condition similar to where clause. So for example, to specify a constraint of salary of an employee must not be greater than salary of manager of the department that employee works for. So we'll write this up. So salary of employee must not be greater than salary of manager of department that employee works for. So considering this as a department, there would be a manager, and then along with the manager we have the department number, then we have the employee, right? So in the department, manager is also a employee, and then employee is employee. Yeah, so it doesn't make any sense. Employee is employee and manager is an employee. So here they are saying that salary of employee should not be greater than salary of manager. Okay, let's write assertion query for this. So first we'll write create assertion, followed by that we'll specify the assertion name, that is salary constraint, and check. So check, and then this sub condition, check not exists, and then we'll write this condition, that is from this table, we'll derive two more tables further. One table as E and one table as M. So assuming that in M table, the manager and the employee both are same. M is for the manager, E is for the employee. Okay, not exists, select star from employee E, employee M, department D. Again, we have a department table also D with the D number and then manager name, manager SSN here in the department, manager SSN in the department. So create assertion name you have specified here, and then check not exists, and then the condition here, that is select star from employee E, employee M, department D, where salary of employee should be greater than salary of the manager. Is this true? This can never be true, right? So considering this table only for employees and this table only for manager. So can employee have a greater salary than manager? I guess it's not possible. So here not exists is true. So we need to check if not exists. So if not exists is true, then this is also true. So this assertion is valid. So I'll continue here. E salary is greater than M dot salary, and E number is equal, E dot D number is equal to D dot D number. These numbers are same, and D dot manager SSN is same as M dot manager SSN. So yeah, these are the further conditions to compare these two. So by this constraint, we can say that this statement is not true. So not true, not exists is true, and then check is also valid. So assertion is valid here. So the assertion is, it has derived some meaning to the assertion which we have performed here. So the constraint name, salary constraint, is followed by a keyword check, which is followed by a condition in bracket that must hold true on every database state for assertion to be satisfied. So this was true, so this assertion is satisfied. The constraint name must be used to refer the constraint or to modify or to drop it. Any where clause condition can be used, but many constraints can be specified here. So here many constraints have been specified. So this is like a nested query example. So this was about assertions. Now we'll look into the trigger part. Trigger is the additional condition, conditional evaluation based on some action. So there'll be an event and the condition would be specified. So if this event is provided this condition satisfies this event, then this action has to be performed. So that was about trigger. So given a condition, if it satisfies, you need to perform some action. So the important statement here is we make use of create trigger, which can be written as create trigger, and then you are specifying the constraint name here, that is salary violation, and then after or before. After or before is like again providing condition. So this condition, before this condition happens, this event should occur, or after this condition happens, this event should occur. So that's what's specified. Before, insert or update, either insert or update of salary supervisor SSN on employee from each row where new salary is greater than, okay, this is the condition provided. Assuming that this condition is true, the value would be inserted before, so by creating a trigger. So inform supervisor that new supervisor is new dot supervisor is, okay, so here we make use of employee has SSN, E name, salary, supervisor SSN. You have a new all these, the values are filled in this tables, and then you have a new record, new row to be inserted in this value. So in order to perform the trigger operation, this particular statement has to be valid. So now that this particular statement is valid, the condition is true, the event has to occur, so the action would take place, that is this new row would be added here. So that's what this says. I've explained it in pretty simpler terms. I would suggest you to go through the PDF ones in which it is specified very clearly. Here the trigger has three events: event, which specifies the database operation, and then the condition determines whether the trigger should be activated or not, and then the action. Once the event has occurred, it is triggered, what changes has to be taken place is specified in the action part. Now we'll look into the views topic. So views are the virtual tables which are created, which may not exist physically. So the command to specify view is called as create view. So we make use of create view and then provide the table name, the view temporary table name, and then whatever the columns we need are specified here, and as. After that, we write the condition. We write the whatever query needs to be written would be written here. And then to dispose the view, we use drop view or drop view that particular table name. So as view is not stored physically in the memory, it cannot perform all the operations. Simple operations like create and drop are okay, but then when you talk about updating view, it is complicated and can be ambiguous. So updates on views defined on single table are feasible if certain conditions are met, but then updates on multiple tables using joins are not accepted at all. So this question could be asked, the topics on views could be asked for 3 or 4 marks. Then we have rules for dealing null values. So null values represent, there are 3 possibilities. It could be that the value is not known, or the value is not applicable, or the value is not available at particular moment. So while dealing with null values, we need to take care of these conditions. That is, if null compared directly, it yields true unknown. That is one of the Boolean conditions. Then in the aggregate functions, we should always ignore nulls, except while counting. While taking the count, we can't ignore nulls. Then we have in arithmetic operations, results in null if any operand is null. In string operations, concatenation with null, you concatenate anything, you get null itself. Then in grouping, we treat null as distinct groups in group by. Then in where clause, we use is null or is not null for null comparisons. So this was about nulls. We'll look into the exist function here. So exist function checks whether the result of correlated nest query is empty or not. So it results, the result is Boolean value. It could be either true or false. It is true if nested query result contains at least one tuple. It is false if nested query result has no tuples. So you write select statement from where, after where you specify exist. So if this has at least one tuple, then it holds true. If not, it holds false. So let's see the example. Here we have one table employee, employee ID, employee name, and then here we have worker. So worker ID, name, and leader. So this we need to get employee ID, employee name of employee who is leader for at least one worker. So select employee ID, e.employee ID, employee name, e.name. Here we are doing the aliasing from employee E, where exists exist condition. Select w.id from worker W, where this condition is satisfied. So this is how we write exist. If the select part, if the nested query part holds true, then this will hold true. If not, there would be nothing would be generated there. So coming to next, we have unique function. So it tests whether a query has duplicate tuples. The result is true or false, that is Boolean. So you write create table department, employee ID, int primary key, defining all the constraints of employee ID. In email, it has to be unique. So I can write unique here. It could be either used in the creation part or it could be used in the nested queries also. So this creation part could be an easy example to write. So that's why I've written this. You can write for a nested query also. Then we have group by function. So if we want to apply aggregate functions to subgroups, we make use of group by. So in group by, we'll group the given values, the given attributes, depending on particular condition. So here select D number, average salary from employee, group by department. So department wise, the average salaries would be grouped here. So that was about group by function. Next we have embedded SQL. So database commands are embedded in general purpose programming language. Okay, that is the host language. So from SQL, from database to the general purpose language, general purpose programming language, here it could be C or Java. So embedding this is done by embedded SQL. So as SQL and host language have different data types, we need to carefully cast data value before passing them or from the SQL commands, because this has one particular a set of rules to be written and this has different rules. So while passing or while embedding these two, you should make sure that you cast data carefully. So embedded SQL, the SQL statements can be used wherever a statement in host language is allowed. They are marked clearly so that preprocessor can handle them before the host language compiler is executed. So the host language, all the programs written in that particular language would be compiled in the language compiler, but we don't want the SQL commands to get compiled there. So they are marked carefully. That's why a preprocessor can easily handle them or identify them. As SQL is set oriented, which may not align with procedural nature of some host language, cursor are made use to address disparity. So we'll look into what cursor is in the further video. So firstly, the variables are declared. So in order to declare variable, host language variables which are being referred in SQL statements must be declared between exec, that is exec is to embed SQL statements. Okay, exec SQL. Then we write begin declare section, and then we write all the statements in the middle, all the programs or the commands, and then we write exec SQL end declare section. So this between this the statements need to be written, and these depict the start and end of a particular SQL embedded SQL statement. This would be same in the host language also with semicolon, and that's the difference. Then we have error handling. In error handling, we have two special variables. One is SQL code and one is SQL state. SQL code returns negative if there is any error encountered, and SQL state tells predefined value with common error conditions. So this is about SQL code and SQL state. Then we have error checking. To check the error, we have SQL state and whenever. So writing an example for embedded SQL, we have exec SQL, that is the embedded SQL statement, the standard statement. Then we write the proper statement here, that is insert into Sailor values, and then here the values. So assuming that this is the Sailor table with name, SID and rating here, a new value would be entered. Here I've just written CS name. You can write whatever value, name X, 2 and 3. So here X2 and 3 would be inserted. So this was about embedded SQL. Next we'll look into cursor's topic. So we have a host program and then we have DBMS. To connect that, cursor acts as a bridge. Okay, so retrieval of rows one at a time, overcoming the impedance mismatch between the SQL based operations and language in like C. So here we have the host and then embedded SQL. So you write a program, the SQL is embedded, then from the DBMS the data is fetched. From the cursor you fetch one by one rows and then get the output. Okay, so that's how the stepwise execution I have explained. So cursor allows retrieval of rows by positioning a particular row and reading its contents. So if not, it will generally keep on reading one by one rows. But then you can make use of position. But if the position of this row is 3, if you specify the position, you can reach the third row and read the values. When we declare cursor on any relation, once it is created, we can open it, fetch next row, move cursor or close cursor. These are the 4 operations which would be performed on cursor. Now we'll look into the properties of cursor. So general form of cursor declaration is that declare cursor name. Then we have insensitive here. So insensitive is like you are making a private copy of result. That is, if there is any change in the main database, the results which you obtain here, the changes will not be reflected here. That is, modify the base relation, but then no changes would be there in the cursor part. So that is what insensitive states. Then we have scroll. Scroll is like you can shift to any row by specifying the position. So that is, it is flexible. Then we have cursor, withhold. Then we have withhold here. Withhold is cursor won't close until the transaction is complete. Like whatever transaction you had written between the exec start and end. So all that needs to be completed, then only the cursor will end. For some query, you have written the query and then the condition further. So for read only or for update, read only or update. So read only is like only used for fetching the result, and update is like you can update, or update here could be deletion and all. So yeah, then we have order by here. Order by is to sort according to a particular attribute or ascending, descending and all. So a cursor can be declared to be read only cursor or updatable cursor for update. The update and delete commands allow us to update and delete. Yeah, this is an example which they have considered. Then here, if the keyword scroll is specified, the cursor is scrollable. This I have explained. Then we have insensitive. Insensitive also I have explained. Then while rows is fetched using sinfo cursor, the rating values is modified in Sailor. Rows by concurrently executing. Yeah, this is also the same. So this was about properties of cursor. Next we have JDBC architecture. So JDBC architecture has first the Java application part, then we have the Java driver manager, then we have the Java driver, and then we have the data sources, which could be Oracle or SQL Server or any other servers. So the first we have is SQL application. So application initiates or terminates the connection with data source. So a set of it sets transaction boundaries, submits SQL statements and gets the results. Coming to driver manager, it loads JDBC drivers and passes JDBC function calls from application to the correct driver. So it handles JDBC initialization, info calls from applications, and call log on all function calls. It performs some error checking also. Then we have drivers. So establish connection with data source, that is establishing the connection to submit the request, return response, translate data, error formatting, error codes into JDBC standards. Then we have the data sources, in which the processes commands from driver and returns return results. So this was about JDBC architecture. Then we have JDBC interfaces. So there are 8 interfaces. Depending on how many marks the question is, you can write accordingly. If it's of 4 marks, then I would suggest you to write 5 or 6, because along with this there would be JDBC classes also. So if combined, if they ask for 8 marks, then you can write 5 for this and 4 for that. So let's look into them one by one, the interfaces. First we have driver interface. It represents JDBC driver, registers driver and establishes connection. Subclasses provide specific driver functionality. Then we have the connection interface. So in connection interface, it represents the connection, database connection in Java. Performs database operations, execute SQL queries and commands, manages connection life cycle and resources. Then we have the statement interface. It is used to execute SQL statements. Statements can be simple, prepared or callable statement. So it provides methods for executing queries, updates and retrieving the results. Then we have a prepared statement interface. So in prepared statement interface, it is an extension of statement interface. Pre-compiled SQL statements are executed here. Better performance and security is provided by this interface. Then we have callable statement interface. It is the extension of this. So extension of prepared interface used to execute stored procedures in database, allows inputs and output parameters to be passed. Then sixth one we have is result set. So result set of query, it represents the result set of query, iterating over row column of result sets. Then we have result set metadata. So it provides metadata about columns. Row set interface provides details about the rows only. So this was about the interfaces. Now we'll look into the drivers. So JDBC drivers, there are 4. First one is the driver manager class. So it is responsible for managing the JDBC drivers, provides method for registration, maintaining and obtaining connection to driver and database. Then we have blob, that is binary large object in database, which is used to handle image, audio and video. Then we have character large object in database, that is used to handle text data, documents and all. Then we have the type class. It contains the constant that represents the SQL types. It is used in conjunction with a prepared statement to set and derive parameter value of specific SQL types. So this was about JDBC drivers. So I have almost completed all the important topics of third module. I would suggest you to go through the PDF ones. There are a few topics which are not covered, so I would suggest you to refer those ones and be thorough with these. So the PDF would be available in description and comment section. I have also uploaded videos for module 1, 3, 4 and 5. This is the third one. So in the next I'll be uploading second module also. Do subscribe to my channel and do share it with your friends. Thank you.